Let's get this started. Good afternoon, my fellow crypto brothers and sisters. Welcome to Brussels. Hope you're having a great time. Thank you all layer for putting this together. Amrit, thankful for hosting this. We have a small subset of very promising projects, companies here on stage. My name is Chen. I'm the founder of TRGC, early stage venture fund, based in Amsterdam. As I have to say, as anyone in here, when I'm not traveling, it's usually my base. Exciting about the conversations I was having early with these guys on the side as we're preparing for this. Before we dive deep into what they're building, let us do a quick intro. Ishmael on my left, Stephen and Mo. If you guys could just quickly tell the audience a bit about your background and the company, your project you're working on.
Good afternoon, everyone. My name is Ismail. I'm one of the co-founders of Lagrange Labs. We focus on building a ZK coprocessor. There's been a lot of talk recently about ZK coprocessors, but to put it very simply, it is a scalability solution. A scalability solution for existing smart contracts on existing chains through verifiable off-chain computation that enables parallel execution and asynchronous composability.
Hey everyone, my name is Steven. I work at RiskZero as the head of strategy. At RiskZero, what we've built is a ZK virtual machine. And what that means in practice is it means that you can build any ZK program, any ZK project in full Rust. So instead of writing a bunch of math, instead of doing a bunch of proofs, you can now build ZK projects, whether it's ZK rollups, ZK coprocessors, or anything in between in full Rust. So that's basically our goal, make ZK more accessible, and we've been working with dozens of projects to reach this goal.
Hello everyone, my name is Mo. I'm co-founder of Brevis. So Brevis is a smart ZK coprocessor that allows your smart contract now have access to the kind of data and the kind of computation capacity that was not possible before through ZK off-chain verifiable computing. So concretely, before we have ZK coprocessors, there's no way for smart contract to have data-driven heavy computation based on historical on-chain data. But with ZK coprocessor, what you can do is that you can now use your blockchain, use your smart contract to have that access and derive very useful insights to do that. And I think everyone in the panel now is offering some solutions to enable your smart contract to do that.
Okay, fantastic. Let's get into it. Two questions on this. Take us back to the exact moment when you guys are your day one, basically, your 0 to 1 moment. You've identified a particular gap in the market, the tech stack, and you're like, hey, wait a minute, I think we can put a team together and start building this and ship this, take this to market. If you could quickly take us back to that very moment.
Yeah, that's a great question. So there was a period of time prior to founding Lagrange where I was working as a smart contract engineer. And I ran into a lot of the problems are related to being able to access historical data about user activity within my smart contract. I couldn't build applications that had the same level of customization and the same level of data richness that I would traditionally expect as a developer of a Web 2 application. So when I found this, and I found this issue, I immediately thought, well, what's the best way to solve this? And through a lot of work from our team and some interesting verifiable computation innovation, we and many other folks on this stage have been pursuing developing tools to make this now possible.
Stephen?
Yeah, so like two years ago, really the only ZK things in existence were ZK EVMs. I'm talking Starkware, Scroll, Tyco, etc. And each of these teams has about a few $100 million of VC funding and a bunch of PhDs and cryptographers. And it was only with those sort of resources that it was even possible to build ZK applications, ZK blockchains. It's that core problem that everyone was seeing, which was kind of the start for RiskZero and why I got so excited about the ZK VM. At its core, it makes ZK so much more accessible. It enables developers that aren't native to PhD-grade cryptography to build rollups to build coprocessors. And yeah, like in that time, I think we've built a lot of libraries, a lot of projects, templates, etc., that have continued down that path. And at its core, it's like making it so any Ethereum developer, any Solana developer, etc., can build ZK applications, build coprocessors.
Mo?
So my story of, oh, is this working? Okay, yeah. So my story of founding Brevis is that, so before Brevis, I actually built a project called Seller. Seller is a cross-chain interoperability protocol, now one of the biggest cross-chain bridges out there, processing still $11 billion transaction volume annually. And we had like 300 partners in the DeFi space, and we just keep a constant chat with them. But we start to really quickly realize that starting from early last year, they all start to demand this type of, and they're all moving towards this modular architecture, where you have a core DeFi and the dApp architecture where you have the core logic, but there are a lot of things they want to be tunable and dynamically configurable via external sources. But there was no good way to do that, really, if you're really relying on on-chain smart contract computation. So this is where we start to realize that off-chain verifiable computing is a very powerful scalable and scalability tool to enable the smart contract to have that access to that type of computation, to that type of data. So this is like why we founded Brevis.
Appreciate that. Let's dive deeper. If you could explain to the audience, what exactly is a ZK coprocessor?
Yeah, that's an amazing question. And so people have been talking about ZK coprocessors in the abstract for quite a bit of time. But now we're at a point in the space where they are concrete. And so what a ZK coprocessor lets you do is to scale blockchain applications, the oldest question in crypto. But it is scaling them through a new approach. You're not developing a different consensus with faster execution, with more parallelization. You're not developing sharding or separate execution logic across rollups. What you're developing is a way to have asynchronous calls from a smart contract to a verifiable off-chain network of nodes leveraging that computation. To put it very simply, your existing smart contract on your existing chain can now access more computation than it could before. You don't need to deploy elsewhere. You don't need to rotate your application to a new, faster L2. You can keep it where it is, and you can benefit from parallel execution and parallel proving that can then allow you to verify this computation back on chain as if it was running with the same security as the underlying consensus that you're on. So this is a powerful new paradigm that developers have begun experimenting with that lets them keep their applications where they exist today and access new features and new ways to prioritize their users.
Stephen?
Yeah, I mean, I think that was a great pitch. The only things I'd add on to that is you can basically scale applications, as he mentioned, and most importantly, you can continue to tap into the liquidity of Ethereum, of whatever base layer your application is deployed on. So you don't need to click on your MetaMask network switcher or anything like that. You can lower gas fees, get a lot more functionality and complexity, and everything for the user remains the same, right? That's the biggest issue with moving on to really fast L2s. It's the lack of liquidity. It's the poor UX. Coprocessors let you scale at the base layer, which I think is really critical to their effectiveness.
So Ismail gave a great summary of how ZK coprocessor works. So I just want to add on top of that why eventually we all need ZK coprocessors and this type of asynchronous off-chain computing paradigm. So oftentimes history rhymes, and I think this time this type of a theory also applies. Let's look at the analogy in the Web 2 space. In Web 2, before 2000, all the web applications are built using a synchronous-based architecture where you have a monolithic web server that does everything for you, and it serves the user request one at a time. It was very clear that this type of architecture won't scale to the demand of the growth demand of internet in the early 20s. And this is why in the modern internet architecture, what we have is a asynchronous-based architecture where the web server itself become a very thin piece of code base that only coordinates between different specialized backend services. And if we look at Web3 today, it is very much similar to what we had in Web 2 before 2000. That is, you're treating the smart contract as this monolithic and very slow, very low capacity server. And how can we scale this is by borrowing the same paradigm how we scaled Web 2 in the last 20 years to expand the capacity via this type of asynchronous computation. Now, why ZKing out of this? Is because we need to have a ZK proof to ensure that the computation end-to-end is only dependent on the blockchain security itself without relying on any third-party trust. So this is like why I think ZK coprocessor is really inevitable to scale the future of blockchain applications.
Ismail, you want to add something?
Really quick point. I think it's a great point. One thing I just want to add is a little bit at the meta level. Every cycle in crypto, we see a new way to try to scale the applications that we can develop. From 2017 to 2021, we had a plurality of L1s being developed. From 2022 to 2024, we see a plurality of L2s. All of them have user bases that have historically rotated between these places, these execution spaces, depending on where there's liquidity, where there's rewards, where there's yield, etc. What we get to with ZK coprocessing is the next iteration of how we're scaling these chains. This is analogous to the first conversations over rollups. This is analogous to the first conversations over new POS L1s. This is a new paradigm for scaling blockchain computation, and a lot of the folks on stage here are the early projects that are kind of pioneering this new approach. And this is why this is an interesting conversation.
All right, appreciate that. Starting off with Mo, let me ask you this, and we briefly talked about this before. Do you think that, or what are the bottlenecks you're seeing for this technology to be widely adopted? And when we talk about widely adopted, I always think about when do the crypto natives in the audience, what is that complexity they see to adopt your technology? How friendly is your project? And I'm looking at you guys as well. What are the bottlenecks you're seeing? And what are you guys doing to make that as friendly as possible to step in for developers to be able to use your technology today instead of in 26, for instance? Because of course we see a lot of promises in the space. What are you guys doing to alleviate those bottlenecks right now?
Yeah, absolutely. So we are doing a lot of design choices in that aspect, and you can look at our doc right now. So right now, using Brevis, you can already do a lot of things, and it's very simple. Using Brevis to build data-driven apps, there are really 3 steps. One, you specify what type of data you want to access on-chain, historical data, events, transactions, and storage. And then you specify what type of computation you want to run using some very high-level API. And finally, you write the smart contract to inject that computation result. So we support the most full-fledged features in terms of the type of data you can access and a lot of very powerful and flexible computation you can run. So this is how generally you can build ZK coprocessor-powered application, not just for Brevis, but generally. But one thing that I want to really put into the minds of the developers and the builders sitting in the audience today is that when you're using ZK coprocessors, you're designing your application in a new architecture. So instead of thinking the application as always a synchronous architecture where every function call will return immediately, now using a ZK coprocessor, you have the capability to access the parallel computing. You have the capability to access very powerful compute, but it's going to be done in an asynchronous way. That the message is going to be sent and invoked to these coprocessors. The coprocessor will do the coprocessing task, and the result will be returned to the smart contract. And then you kind of resume your business logic from the point you send out the message to the point you pick up the message in your callback function. So this is like how design of ZK coprocessor powered application is going to be different from traditional applications. And this is what we're trying to make this experience very smooth. And if you're interested, you can look at some of the recent things we did with Uniswap Foundation. They recently launched the Uniswap Hook Incubator, and a lot of developers actually build full-fledged Uniswap v4 hooks using Brevis to build data-driven hooks. And this is like you can see how each of the steps is done in this process.
Stephen?
Yeah, so on the DevX side of things, I'd recommend folks to check out our Foundry template. So at its core, you can basically build a coprocessor with 2 files. And that's the key that we're trying to enable, right? You have your smart contract, which sends the request and handles the callback, similar to Mo's approach. And then you have your Rust-based guest program. And that's where you put all of your logic. Whether it is an order book, a liquidation engine, something to do with Uniswap hooks and pool rebalancing, your core logic remains in the guest in Rust. So you can build all of that there. You can build it and make it as complex as possible because you don't need to think about things like gas. And all of that is automatically connected back to the smart contract in this template. So we wanted to make the development process as easy as possible. You don't need to think about any sort of infrastructure, any sort of linking files to connect your Rust file down to your smart contract. So yeah, I think that's kind of how we've been thinking about DevX. And as Mo mentioned, I really want people to think about this new architecture and approach when they think about their application logic, right? Like all of your logic is living off-chain async. How do we build our applications to really take advantage and leverage this? Can you move all of your core computation off-chain? And then can that off-chain computation be connected back on-chain for the state transition itself? So it's a completely new way of thinking about things, but one that's extremely powerful and basically circumvents any of the traditional limitations of gas and EVM.
So thank you, Mo and Steven, for those great points. Two things I just want to briefly touch on, because I think this has covered a lot of the design pattern of a coprocessor. But similar to both Brevis and to RISC-0, to interact with Lagrange in production today, you would want to make asynchronous calls. It's an asynchronous design pattern. And so we're in production. We're on 4 chains. We've done about 2 million proofs over the last 60 days across our network. And we've had about 83,000 developers make queries. We have great docs on how to do this. It's all on our GitHub. People can go see. We also have an Explorer that shows you how to do all this stuff. Now, to get away from the company-specific details, just more to the developer ergonomics, it's a new paradigm. There will always be bumps and learning curves, in my view, for developers to learn how to interact with this. The original question on how can we get people to actually use coprocessing. But the way we've seen in crypto historically is that there are going to be killer apps that have driven developers to develop an appreciation for how to interact with these new tools. We see this on L2s, we see this on L1s, and the belief that we have is that rich on-chain experiences built by teams like Lagrange, teams like RISC-0, teams like Brevis, are going to be some of the things that champion how developers in this new paradigm will interact and how they will choose to build their applications. The moment a few marquee companies start succeeding by leveraging coprocessing at their core, we're going to see an explosion of developers, and ideally, we'll see refinement of the ergonomics across every team in the space to be able to match this new influx.
Thank you for that. We have about 90 seconds left. Real quick, it used to be a buzz, CK is the end game. I want to get this in there. CK is the end game. Now, the CK Sync token came out, and suddenly there's doubt in the community, the general crypto community. So, quick bullet point. I want to hear your quick response on this. Do you think CK is the end game? And does the CK Sync token, the performance of it, have anything to do with whether or not we should be bullish about it still, or we should stay on the same path?
This is a phenomenal question. Thank you so much for bringing this up. The way we see it is that ZK is foundational to the future of crypto. It's been discussed by most of the leaders in the space. It's almost a consensus opinion. If you were to ask most people at a conference where the space is moving, they'd say ZK. Short-term performance of price is very unfortunate, right? And a lot of people will lose confidence and may lose confidence in a thesis because of that. But what we know is that we've seen across cycles the technology that is foundational to where we are moving as the things that capture and accrue value. And ZK and many of the teams here, we believe, are going to change this and are going to be the teams that have some of the most well-performing assets in the space.
Stephen?
Yeah, like moving computation off-chain, which is the core idea of ZK, is principally going to change how we think about scaling and change how startups and roll-ups and Web3 moves forwards, right? Like the vast majority of tokens or anything new these days are for layer 2s, parallel EVMs, things like that, things that are still restrained by consensus and distributed systems. ZK and the end game of it is moving completely away from all of this. It changes how we think about rollups. It changes how we think about scaling. And I think the end game here is one kind of in between the current paradigms of rollups and like L1s. And things like coprocessors, things like async off-chain computation will be leading that charge.
Appreciate that. Mo, closing remarks?
Yeah, absolutely. We definitely fully believe that ZK is an end game. And, for all the ZK, right now, like the first application of ZK computing migration, because ZK provides the capability to migrate the compute from on-chain to a different world. And, what we see is ZK rollups. And ZK rollups amazing application for ZK for sure. And, but that's not, the price and all that stuff is related to how the ecosystem grows, works, and how the market cycles in general. But we do believe it is just opening the first chapter of how ZK can transform the computation capability and the application possibility of the blockchain applications. And, I believe in the next couple of years we will see probably a much larger amount of computation done in off-chain comparing to the on-chain world. And this is where we see the industry is heading towards.
Fantastic. Well, folks, unfortunately, that concludes our panel. Thank you so much for coming. Thanks for your attention. Ishmael, Stephen, Mo, let's give them a warm applause. Thank you so much, guys. Thank you all later.